Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem of medium type, that is longest increasing subsequence. So we are given with an array of integers and we have to find the longest strictly increasing subsequence. If we don't know what is subsequence, so subsequence is also an array of the same length or a smaller length that can be derived from the original array by deleting some or no elements without changing the order of the remaining elements. So if we take this array, so this is also a subsequence, the highlighted part. 37101 is also a subsequence. Even empty and the whole array is a subsequence of itself. But the condition is we have to find the longest increasing subsequence. So if you can see that 237101 is the longest increasing subsequence. The length is 4. So let's see how we can do this by understanding in a brute force manner and then doing the deep and then moving it to DP, dynamic, solving it by dynamic programming, top down approach. So if you'll see 21, let's take an example, smaller example, 2134. So if you'll see, we can easily see that the longest increasing subsequence here is 234 or 134. The both are strictly increasing, so and both have the longest 3 as a length. So it's okay if we take either this or this, because we have to return the length, not the values. So according to the brute force, if we go by brute force, the ways a number can be included and non-included, that's the way we will apply brute force. As either we can include 2 or we don't include 2. Either we include 1 or we don't include 1. Either we include 3 or not include 3, or include 4 or not include 4. This is the brute force we can do. So the total ways in which we can derive all the possible subsequences are 2 to power n, that is the length of the subsequence, that is 4, that is 16 ways. For example, 2, 1, 2, 1, 3, 34, and deriving all other 16 possibilities for this array. Now let's see how we can do this for the strictly increasing subsequences. So when we talk about strictly increasing subsequences, so this is not the subsequence we can go for, because 1 is not greater than 2. So the next element, this 1 has to be greater than 2, because 1 is coming after 2. So the elements coming after the previous element has to be greater than the previous element. So how we will see at every point, like whether it's greater than its previous element is or not. So we'll seeing the previous element to compare. Like if I compare, if I'm on 1, I have to compare it with 2, and if I'm at 2, I have to compare with some previous element. So let's take this as minus infinity. So we will write a function that is f starting with 0th element, and let's start with the previous element as minus infinity. So at every index will either we can pick that element or not pick that element. Either we pick it or we don't pick it. So starting with f0 comma minus infinity, that is the first input is the index of the array, and the second part is the previous index, a previous value. So we are at 0. So there are two ways we can take, that is either we can include 2 or we don't include 2. So the blue will blue means we do not include it, and green means we include it. So if we do not include 2 in our a maximum increasing longest increasing subsequence, we'll go to 1 and again we have two possibilities, either we can include it or we don't include it. So from 2, when we move from 2 to 1, we'll increase our index, that is from 0 to 1, but the previous element will be minus infinity because we are not including 2. So when we reach 1, I think the first index, if we are starting with 0, then at first index the previous element will be minus infinity. Again, from 1 we have two choices, either we can include it or we don't include it. So if we from 1 to 3, by not including 1, we'll again increment the index, but the previous value will be minus infinity. So we reach 3, that is the second index. Now from 3 we have again two choices, either we can include 3 showing with the green pointer and we don't include it with blue pointer. If we don't include it, we'll again go for the next element, that is 4th, by increasing the index, and still the previous value is minus infinity. Here again we have two choices, either we can include 4, the green part, we don't include 4, it is blue part. So we'll increase the index 4 with a minus infinity because we have not included 4. So but here we reach the end, we are out of the array, so we'll return 0 from here. Now when we reach 4, now when we backtracked, we came 4 and we can see we have to take the another possibility, that is by taking the 4. If you see, this is, if you go by this line, blue line, from top to down, it's one of the path by not taking anything, that is empty. So empty array is also a subsequence and it's also a increasing subsequence, but it is not the longest. It's part of the one of the possibility of the answers, but we will check by following other paths too, whether it's the longest or we have some other longest increasing subsequences. So we were at 4, so we have to try that. Let's say we are not taking, let's say then we have to try with not taking plus taking. So if we take 4, we again go to the next index, this is out of bound, then we'll return. But here is a point, that if we take 4, then we have to increase our length because we are taking it, so it will be plus 1 from whatever the previous we were coming with, because it's saying include me and move on. So we are out of the array, we will return plus 1 as it is, because it will return 0 and 0 plus 1 plus 1. Now we are at 4 and we have traced back by not including one of the path. So we'll go back, we'll take the maximum from this path and this path, maximum of the two. So 0 and 1, the maximum is 1, we'll return at 3. So we came here, we are here. Now again we went with not including 3. Now we'll see another possibility by including 3, that is plus 1. So if we didn't include 2, we didn't include 1, but we are including 3, 4. That is one of the path from, if we follow this and this line. or this line. Maybe we can only include 3 but not 4. That is also the possibility. So we are at 3. If we are including 3, we'll reach here f3 comma 3, that is increasing the index to 3, 0 1 2 3, and the previous element as 3. So when we reached, if you see, we might have, you can notice here that if we are not taking it, the element was previous that was coming, that is minus infinity. If we are taking it, then the previous element becomes 3 and we reach 4. Now at 4 we have two possibilities. I think we can take it or not take it. So if you see this whole graph, I have drawn it by taking and not taking all the possible ways. So drawing all the ways except we have to check. If you see here, we were at 4, then we return plus 1. Now the maximum again at 4, we'll take the maximum of 0 and 1, that is will be 1. Now again when we took 3 and we took 4, the maximum will be, return will be 2. We again are at 3, we'll check what was the maximum from here, that was plus 1. What was the maximum here, that is 2. So what is the maximum from 1 or 2, that is 2. We'll go at 1. So if we are at 1, what is the maximum length of the longest subsequence ahead of 1 is 2. If we say 2 1 3 4, if we include 3 and 4 from 1, so at 1, what is the maximum length of the subsequence ahead of 1 is 3 comma 4. That's 3 and 4, that is of length 2. So again we will backtrack to 1 with a possible with the maximum length of 2. Now here at 1 we took the non-take part. When we didn't include 1, we can also include 1 and do the same process. And after doing this process, we'll see that if we include 1, the maximum we'll get is 3. That makes sense, because if we include 1, include 3, include 4, at position 1, by including itself, the maximum will be 3. Now what we have to see, one point is, if we are at position 2, then we saw the non-take part. Now we can see if, now after tracking we got that the maximum length by not including 2 was 3. So we can also see that what if we include 2 as well, and do again the same process of finding of taking 1, not taking 1, 3, 4, again going down these paths. So we'll see if we are taking 2, that is plus 1. So now we have taken 2 from 0 comma minus infinity. We'll increment our index, that is 1 will reach 1, and the previous element will become 2. Now from 1 we have again two choices. Either we cannot include, we don't include 1, or we include 1. But here's the main point. Here's also one point that is main, that if you are not including 1, then it's okay. But if we are thinking of including 1, we don't have to do it, because we want the longest increasing subsequence, right? So here we also saw that when we reached from 3 to 4, we included it because 4 was greater than 3. But now here you will see that when we went from including 2 to 1, So now 1 is smaller than 2 and we want strictly increasing, so we'll not take this path, we'll skip this path. So this is the brute force that we can see, and this complexity is 2 to power n. Now we will see that how we can optimize or memoize this function. So let's see the code first for this algorithm. So if you see, this is a pretty basic recursive method where we say that our base condition, if the I, we will take the two parameters, that is I and previous, as I stated. We'll enter every node or every path with index and the path. Now we'll say our base condition, if I is greater than or equal to array.length, will return 0. Now we have two choices, either we can take it or we don't take it. So if we don't take it, we can again recurse on the array with the next index and the previous element as it is. Now if we want to take it, then we have to also see that the array at the index we are on at has to be greater than the previous element. So it's this condition. So we wanted to take 1, but we should not, because we want the strictly increasing subsequence. So if this condition is passing, we will increment our count or the length of the subsequence, and at the end of the recursion we'll have to take the maximum of take and don't take. So it's a pretty basic recursive formula. Now let's see how we can memoize. So if you see here, at every stage, at every node, we have index and previous index, like value, the current index and the previous value, or we can change this to previous value to previous index as well, but the element present is the previous index. Now and there are lots of duplicate iterations, like if you see here 4 and minus infinity, again we are doing for 4 minus infinity, we are doing for 3, here also we are doing for f3, means when the current index is 3 and the previous value is 3. So there are lots of unnecessary recursions or recursive calls that we can avoid to bring down the time complexity to n square. So that's what we are doing with DP by memoizing it. So the best way to find how we can take our DP array, so we can take it first of all the 2D array, so that first index will tell you the ith element, ith index, and the second will tell us the previous element, previous index. So for every I and previous, we can store the result, and whenever in the future we get the recursive call for the same ith and the previous index, we will have the data stored in our memory in the memoization. Now let's see the code for this. So let me sorry for this. Now, as I said, we have to first initialize a DP for our memoization. That will be a 2D array. Now, how to decide the length of the 2D array? So if we will see, our index can go from 0 to n, because at n we decide that we have to return 0. and also our previous index can also go from 0 to n, and we'll take -1 to n basically, or so length we will take from 0 to n, the same for index and the previous index. So we'll have our dp with nums.length plus 1. We'll initialize the 2D array with -1 with all the elements as -1. Now let's see how we can write for the code of the memoization. So the best way to, as I said, the best way to declare the dp is to see what value we are taking as an input for each recursive call. So we have I and previous as the value for each recursive call, so we can put it in our dp as a 2D array, one for ith index and other for the previous index. So there can be n into n combination for the dp, so that's why it's a 2D array with n into n length. Now if dp.index.previous plus 1, why previous plus 1? Because we are passing the previous index as -1. So if we do dp index previous, it will not work because -1 is not the correct index for any array, so it's out of bound. So we have to increment by +1 so that it points to the 0th index. If it is not -1, we'll return the dp of index previous as it is. Now this is our base condition. If the index reaches to the n, then we'll return 0. Otherwise we'll recurse with the index +1 and the previous element. And if the previous is equal to -1, it means if it's the first start of the recursion that we started with 2, so we have to do the take part, because this is the no take, because we are not taking the current index as a previous value, and this is a take part because we are doing the 1 plus, same as before. When we were taking, we were doing the increment, and when we were not taking, we were not doing any increment. So same part, but for previous equal to -1, just to start the process for the take and non-take. Otherwise, if the previous is not equal to -1, then we have to check that the array value at index has to be greater than the array value at previous, and finally we have to take the maximum of both no take and take, and we will store it in our dp with each iteration. So if we see, like if we come back here, so we'll store this, and at this value after doing the recursive call, we'll store this as well. So every node will get after the recursion, it will get stored in the dp, so that in the future, like this f3,3 will get stored in the dp, so that in the future another recursive call for f3,3 we can return that part, and will save some of the recursive calls. So, and finally we'll return the length. So this is the approach when we are going with the memoization. So let's run this with the memoization approach. So test cases are passing. So hope you like the video. Please share this and subscribe this video. It will give me motivation to make more such videos, and thank you.